Hi, Meta from Moxa here, and in this video I'm going to show you just how easy it is to configure the MGate 5192, a secure, rugged, and easy-to-use IEC 61850 client gateway specially designed for the needs of power substations and renewable energy systems. When retrofitting a substation, you may need to connect various IEC 61850 power devices, such as IEDs or relays, and connect them to a SCADA, which may use Modbus DNP3, IEC 101, or IEC 104. But integrating all these together can be complicated, difficult, and expensive. So we designed our MGate 5192 to make these protocol conversions simple and economical to implement and maintain. Today, I'm going to demonstrate how you can monitor an IEC 61850 IED with a Modbus TCP SCADA and perform basic communications. For this demo, we're going to monitor the operating frequency of our IED, and that can be used to monitor the operating frequency of an entire power system. Now, the operating frequency is important because it determines the parameters of a lot of components in the system, such as generators, transformers, and other electrical equipment. If a frequency drop is detected, then the IED needs to trigger protective actions to prevent a power outage. So we have our IED, which runs IEC 61850, and we've connected it to our MGate. And our MGate is connected to a laptop that's running a Modbus TCP simulator, which we're using to represent our Modbus TCP SCADA. I'm going to show you how to configure this conversion in just 4 steps. To get started, we'll need to log into the MGate's web console. By default, the IP address is 192.168.127.254. When you connect to the MGate for the first time, you will need to create an administrator account name and a password that is at least 8 characters long. Click on Network Settings and set the MGate's IP and other related network settings as needed for your network and application, then click Save, and the MGate will reboot. After the MGate reboots, connect to the MGate using its new IP address and log into the web console again. Next, we need to select the protocols the MGate is going to handle by going to Protocol Conversion. Our southbound edge device is already set to IEC 61850 server to connect to our IED. For our northbound device, our MGate can connect to Modbus, DNP3, IEC 101, or IEC 104 clients. For this demo, because we're connecting to a Modbus TCP SCADA, we'll set our northbound device to Modbus TCP client, then click Apply. To set up southbound communications to our IED, go to the IEC 61850 client page, click Server Settings, then click Add Server. The MGate will start a wizard that guides you through the process. First, we'll need to import a substation configuration language SCL file, or a configured IED description CID file. Click the Choose File button, select your SCL or CID file, and then click Upload to upload it to the MGate. After uploading the file, your IEC 61850 device's basic information will appear. Specify a server name to identify your IED and adjust other settings as needed. Now we can specify the data we want the MGate to handle. Configuration of this data is separated into 2 parts, report and request settings. The main difference between these is which device triggers the communication. Report data is data the IED actively sends to the MGate, and request data is data our MGate will request from the IED to read or write. Under Report Settings, click on Add Report to configure a report and the trigger conditions for data coming from the IEC 61850 IED, then click Next. Under Request Settings, click Add Data to configure the data on the IED that you want to read or operate on from the MGate. In this demo, we want to monitor the frequency of the IED. So we're going to go to the Read Data tab and click Add Data to add the details for the frequency data so that it can be read from the MGate, and then click Done. We also want to adjust the integrity settings so the MGate pulls the read data every second. So in the Read Data tab, we'll click Edit, then set our integrity interval to 1000 milliseconds. If you need to write or operate on other data, like if you need the IED to open and close a relay, then you can add data tags for them under the Operate Data tab. After specifying all the data needed from the IED, click Next. On the next screen, you can view all the configured reports and data objects to read and operate on. You can set up data scaling and calculations on this page by clicking on the data object's pencil icon to edit its scaling settings. When you're done, click Next. Last, we have a summary of our configured IEC 61850 server settings and data tags to convert. Make sure everything's correct, and then click Done, and then click Apply to activate the new settings. You can go through all of the configured data objects by clicking on one of the servers and then checking the Overview tab. Now that we've created our IEC 61850 data tags, we just need to choose which data tags we want for our northbound Modbus TCP SCADA. Go to the Modbus TCP server page and click TCP. Click the Edit button and configure the Modbus TCP server ID and TCP port if needed, then click Save. For the data mapping between protocols, click Add Tags to select the data tags to use for mapping. Here, we'll select IEC 61850 client as our provider, and for selected tags, we'll use the checkboxes to select the data tag we created for frequency. Then we'll click Done. Now in the Data Mapping tab, we can see our automatically mapped tags and the Modbus TCP function codes and addresses they are mapped to. Last, click Apply to activate the Modbus TCP settings. Now we just need to set up our Modbus TCP SCADA to read the data by using the parameters shown on the MGates. To verify whether the MGate is retrieving the frequency value correctly, just go to the Tag View page to see the tag and when it was retrieved. Now we can monitor the IED's frequency value on our Modbus TCP SCADA. And as you can see, in both the IED and our SCADA, the value is 50 Hz. So as you've seen, the MGate 5192 gateway makes it easy to convert IEC 61850 to other industrial protocols. It guides you through the configuration process, and it can convert IEC 61850 to Modbus TCP, RTU, and ASCII, DNP3 TCP, UDP, and serial, IEC 101, and IEC 104. And on top of all of this, the MGate supports up to 5,000 data objects, making it perfect for large data communications applications. So for more information, click on the link in the description. Thanks for watching, and see you next time.